Yeah, so this is Coffee Compiler Club, and we're here to talk about compilers and language runtimes and garbage collection and register allocation, if that comes around today, and anything else that seems sort of related. And unrelated, I had firemen come on my balcony and use my house as a lookout for a fire that didn't exist. So my house didn't burn down yet again, but it was very entertaining. And then Cameron threw me a link to let me make sure didn't pick up any extra people. No, threw me a link to a nice blog write-up, and it's in the Google Docs for register allocation constraints. And let me go find that. There it is. Anyhow, I don't know if people want to talk about register allocation today. I always liked register allocation. I had a long storied history with register allocations. I have lots of things to talk about it with it. Okay. My wife's telling me she's back in downtown, running around, cleaning up the house. It takes forever to buy a house, and it takes forever to sell a house, and it takes an endless number of nitpicky, stupid things you have to go do for months on end to get your house done, sold, even after the offer's made and we're all on board. This is what's going to be. No. Crossing your T's and dotting your I's takes freaking forever. Fine. I don't know. People want to talk about register allocation? Anyone in here doing it, actually doing it, or planning on doing it? Like Max Bernstein's not on, but he probably has to do something with register allocation, or is he going to lean on LLVM?
Well, we use a register-based VM, so we do register allocation, but we have the benefit of having an infinite number of registers. So
yeah, it removes 99.
The allocator is really easy. It's
yeah.
01.
Yeah, 99% of your problems go away then. Yeah.
So what's doing the actual register allocation? LLVM?
Eventually, yeah.
Eventually, okay.
We're not that far yet.
Gotcha.
We're still running in an interpreted mode.
And how strong is LLVM register allocation?
This I don't know. Actually, I do kind of. I stared at Julia LLVM producing code for Julia, and it was what I would call classic good C code allocator, which in the land of Java jitting, it failed to make any intelligent cross call optimizations, which the jitter would totally go to town on. It failed to have performance information for profiling information for what blocks are hot or not. I know Arthur's here, and I know totally he's been working on doing that with LLVM. So there's probably something there to be done to make it better.
So I haven't tried it firsthand, but the reputation of LLVM is it does well as long as you have big enough compilation units. And the way Julia gets itself into trouble is that it tends to have really tiny compilation units.
Definitely, there was a lot of cross-call overheads that were abusively large. They did all cross compilation units with an indirect bounce as a starting point. And so that immediately throws in an indirect jump on every cross call. So if you only have big units, yeah, you're fine. If nothing's hot inner loops, you're fine. If you have unresolved virtual calls on your inner loops, you just sucked it.
So it can definitely use the profiling information, but you need to provide it. And I don't know, maybe their compiler just does not provide this information.
Julia was not providing it. Yeah. So the compiler heuristics were kicking in, and they were doing things smart around loops. But if you look at the hotspot, we took the profiling data over the loop profiles. If you didn't have profiling data, we did loop depth. But if you had profiling data, that trumped loop depth.
The area where we needed to invest was specifically around save points and having, for example, GC values on registers. So that's the area we had to work and improve. But as a general register allocator, we're pretty happy with the
result. Okay, yeah.
So
the other thing I did with Hotspot was have different calling conventions for everybody. C code, native C code had whatever it had, and the interpreter had a particular convention, and the calling JITted code had a convention that knew it was calling JITted code. So you could do things like pass floats and float registers, whereas the C convention got all var args crazy and was trying to pass floats and int registers and shit like that.
So for those that are not so into it, what is the 1 minute intro for register allocation?
Which the 1 minute, what's the issue?
Yeah, what's
Yeah,
the
it's NP complete. There's no, well-known, good, efficient algorithm that is always going to give you the correct answer unless you're just exponential. And the numbers that you can get are interestingly large constant factors for performance. So if
When you
do
say can't give you the correct answer, you mean can't give you an optimal answer.
That's right.
You can at least get a color.
You can get allocation. So don't say coloring, because that's a graph coloring allocator, which is self, but the article that Cameron put out is not a graph coloring allocator. The past one in Hotspot was not a graph coloring allocator. I don't know what LLVM does, honestly. Graph coloring allocators have a reputation for being slow and giving good allocations. The one I did at Hotspot was actually the fastest graph coloring allocator I'd ever seen by a large margin, but it still was slower than a good, efficient linear scan allocator. It did give you much better colorings. So the performance numbers I've seen out of an allocator typically give overall performance on random junk code of, worst case 50%, more likely 10%, depending on where you're at. So a bad, stupid allocator thank you, Matt, might give you the 50% lossage because you're just spilling everything everywhere. Like if Cameron took his infinite register allocation and just simply put them all in a stack slot and loaded for everything and stored for everything, you could expect 50% lossage over a good allocation. If you had a decent linear scan, you're maybe 20% lossage over the best of breed, whatever, graph coloring or whatever it is. So LLVM's, Matt's saying, is not using graph coloring, but they're doing a decent job. So there are other things in graph coloring that do decent jobs, but you have to start getting smart about loops and loop depth or profiling data, and you have to get smart about where you split live ranges or spill them, because the naive technology for doing that will end up with all kinds of loads and stores and hot inner loops that will, drive up that's where your cost goes. So that's your 1 minute, what the hell it is.
So the main critical point is not spilling registers.
Not spilling them in bad places. You must spill. You have no choice. You will always spill. Okay, not always, but trivial programs, trivial methods won't spill. Nearly everything of interest will spill. Certainly, if you're doing inlining to avoid other overheads, like the standard calling convention overhead will be register, callee, caller saves. That's effectively spilling.
So what's the ratio of a spilling versus spilling on the wrong place versus the?
That's what I was just saying. If you
what's
do
the performance difference?
Yeah, if you do naive, you might be like 50% worse because you're issuing loads and stores that are L1 cache hits, but they're loads and stores with their delays versus direct register uses everywhere. Oh, Arthur just got dropped. Damn it! This is sort of up his alley as well. There he's back.
And the performance difference sometimes, some numbers like 100 to 1 if you're spilling.
No, 50%. So if you do dumb job, I would claim you're probably not worse than 50% off of a really good job. But the really good job can apply where other things like loop optimizations, they're hit or miss. If you have a hot loop, you get giant wins out of loop optimization or giant fails if you don't, right? Register allocation generically applies across the board. All programs get lifted by the rising tide, but they get lifted by a more modest amount than loop optimizations, which, like I said, they're hit or miss. You're on or you're off. Okay, so 50% is a reasonable number. The other things that will count more for a while will be enough inlining. If you fail to get enough inlining, you'll pay a lot of that overheads, and you'll get the same register spilling costs, but put in your prologue and epilogue instead of as spill cut.
If you inline too much, does this affect register allocation?
Exactly. So one of the main wins out of Hotspot was I got the allocator to not do worse than loads and stores on the calling convention. That meant I could inline more aggressively. Up until then, I had worked on quite a few industrial quality register allocators, there was always a knee in the curve where you turn on inlining too hard. There were too many live ranges. The allocator couldn't deal, and he would start to spill, and then he would spill every fucking thing on the planet, and you take your 50% hit. You would take that bad hit, even on an otherwise a good allocator, because you just had too many live ranges. So, you know, you get x86, you got, you know, ignore the stack pointer, you got 15 real registers to deal with. A lot of people even eat one, you get down to 14, whatever. If your set count of live things is, you know, 16 or less, you probably spilled hardly at all, and you got it right. It was all good. And if your live range count simultaneously live hit like 30, you started to spill a lot for most of the allocators I looked at. If you're on a Spark, Itanium, ARM 32 register machine, you double all those numbers. People write big programs, those numbers get doubled all the time. After you inline, they double a lot more. So as soon as you hit some big number, was more than your current set of registers, you brought into play the spilling heuristics in your register allocator, who, as I mentioned before, it was very easy to get into this bad pattern where everybody fucking spilled everywhere, and you got a horrible allocation, and that was your 50% lossage right there. So instead, you dialed back inlining to avoid falling over that curve on average through a large set of programs. So inlining and register allocation totally play hand in hand. And you know, the hard thing I did at Hotspot was to make it not spill so bad when you over inline. And then I inlined very aggressively and got a tidy win out of it. Honestly, that was one of the big wins that made Java, you know, comparing to C code and C quality performance. You know, I got some really good numbers out of it because I could inline where the C compilers would not, because they were too scared of register allocation fails.
Since we're on this topic, let me promote my recent talk. I recently gave a talk on inlining in our compiler. So
link.
I'll post the link in the document.
Yeah. Well, you gonna talk about it now? No, you're trying to put a link in. My wife's telling me that I need to get
engineers and their single-threaded capabilities.
Yeah, it's true. I do not multitask well.
Yeah, I'll post the link, and yes, if folks will have questions after watching it, we can discuss it next time.
Yeah, well, give us the 30-second, you know, pitch.
So yeah, we do top-down inlining. We iterate simplifications in the top-level function with inlining, because simplifications can open new opportunities for inlining. Then we also do a limited form of bottom-up inlining. So when we are preparing our candidates for inlining, we actually inline small methods into them. So this way we can eliminate things like getters, setters. We can basically canonicalize our inline candidates, so we can see more simplification opportunities in them. And we also do cluster inlining, where we recognize that there are several call sites that, when inlined together, can bring some extra benefits compared to inlining things one by one.
Yeah. How do you track that? What's the heuristic?
So we have our inliner makes the decision based on benefit and costs trade-off. So we can compute benefit and cost for individual call site. So cost is rough estimate of the size increase, and benefit is it's a measure of how many interesting transformation will happen in the candidate in case we inline. So based on the arguments and other things from the caller
becoming constant classes and the like.
For example, like the virtualization opportunity, you have an exact type passed as an argument, and you have an indirect call on it. Well, it's an interesting optimization that will happen after inlining. It gives some benefit for inlining. Okay. And then for clusters, we our inlining decision is not a single call; it's a cluster of calls, and a single call is just a trivial cluster of one call site. So we extend the notion of costs and benefits from single calls to clusters. It's just an aggregate of costs and benefits, but then a cluster can also have some extra benefit. For example, if a cluster can make an allocation fully unescaped, it has benefits of individual call sites, but then it has this extra benefit of making allocation fully unescaped.
What do you use to define a cluster?
So it is just a group of call sites that can be inlined together. either sibling call sites or nested call sites.
But so why? Yeah, that was a self-referential answer. Right? That didn't answer the question. All right, fine.
Although, can you elaborate the question then?
Is this like all of the calls inside the body of a loop, or how do you
Right.
scope that?
Here's a large method that I've done some inlining on. I got a few hundred call sites yet to be inlined. Here's a few hundred calls. Group them.
How we identify clusters that are worth inlining. Is this the question?
Yeah, how you identify a cluster, right?
Yeah. So we have different clustering heuristics that try to find them for different reasons. And currently, the heuristics we have like checked in and working, they are all about escape analysis and making allocations fully on escape. Like either if we have an allocation in the caller method and we can make it fully on escape by inlining set of calls, or for example, if a call returns an allocation and then we can like make this allocation fully on escape by inlining this call, something inside of this call and something in the caller method.
Gotcha.
But we are thinking about other clustering heuristics. Like, for example, you return an exact type from one call, and then you pass this value to another call. And if this information flow can give you some opportunities, you can get extra benefits for inlining them together.
Yeah, okay.
We haven't implemented this yet, but I think that the general notion, okay, we can have different heuristics identify clusters of calls to be inlined together and compute their benefit when they're inlined together. That's the general idea.
So right now, what I heard the heuristic was, we walk the set of calls and we whip out a heuristic that we run across all of them. And this gives us sometimes groups of calls that will now make a cluster, where the heuristic says, I looked at this call and I looked at his neighbors in some call graph, both up and down the call tree, and decided that these neighbors would fit well together with some particular opportunity in mind.
Yeah, and we can have different heuristics populate, but we have a priority queue and we can populate it with different clusters, maybe overlapping clusters, and then the prioritization in the queue will choose the best cluster to inline, and then we'll reshuffle the queue.
And reshuffle the queue. And then there's some cutoff, I assume, where you decide that you're getting too big and it's time to quit here.
Yeah.
Yeah, Hotspot started with a simpler place, and I didn't get a chance to do sort of proper inlining. So we ended up making our inline decisions sort of before the main optimizer ran. So it had things like all the getters and setters, you just hard inlined, and things that you could tell were going to be inside loops with a naive loop walker that was basically back edges on bytecodes, would be obviously candidates for inlining. Then you use the profiling data. So this call site was hot, but I couldn't tell you if it was hot on this particular path, but this called target was hot, and this function call leaving from here was hot. And I don't know if this one called that one, but that's what the current type said. So then we try to go inline that way. So it was more profile driven. There were some heuristics of size, getters and setters, and then some profile driven, but not looking for things like escapes and not looking for add-ons like this is going to devirtualize after inlining. It was simply profile driven.
Yeah, and this ability to iterate simplifications and inlining, and ability to discover new facts and then use these new facts in order to see, okay, this will enable this simplification. That's a powerful thing.
Yeah, I totally agree. So one of the things that would happen to us, for instance, is that we would see, I have a call site that is hot and I have a call target that's hot, so I'm going to inline it and I do all the work. After I'm done doing my analysis, I discover that the path leading to it in the greater method after other inlinings happen is dead, and I inline and did all the work to the analysis, and in fact it's dead code. So I chop it off because it's dead, but I paid the price anyhow. Right. So that kind of shit definitely happened.
Inlining is what they call the mother of all optimizations.
Yeah, under the current world order, if you're in the Fortran era, loop optimizations win, but modern era, inlining first. Once you get past the inlining, then the loop optimizations, they kick in, they're valuable. People still compute weather.
I don't know, I think if you turned off loops in the JVM, you'd be amazed how much stuff wouldn't run.
Oh yeah, performance would just be, well, people, I've done those tests. It does get ugly, but you have to inline to get to the point where the loops get interesting. Sorry, somebody cut off Arthur.
I think it was
People
Arthur.
write a lot of small methods, like they layer their abstractions heavily, and yeah, that is why we need to inline a lot in order to.
When I was compiling C code, not nearly so many layers of abstraction.
Yeah, and we can actually see this effect even in Java. For example, if you look at old Java code, if you look at spec JVM, for example, you don't need a sophisticated inliner in order to handle this.
Yeah, not for JVM. Yeah, I mean JVM
Yeah.
98. I'm sorry, spec JVM. Yeah, I guess
Yeah,
I'm not 98 anymore, but yeah.
But modern code with streams, lambdas, etc., it takes more sophisticated inliner to do well on it.
Spec JVB wanted more inlining.
Yeah.
But also being good at inlining enables you to do things in the way you write code you couldn't do before. Java gets away with its getter setter model. That means you can have the flexibility of these things potentially being functions without having to pay the cost of it actually being a function call every time.
I have a different comment about love or hate for getters and setters in terms of when I use them. But yeah, from the JIT's point of view, they're an obvious thing. You go inline it.
I can say
To the
that
point where languages like Ruby just said,
Yeah.
everything's actually a getter or setter. And even though the syntax says A dot B equals C,
Yeah, it's all.
that totally might be a function call to the setter on A under the hood. And
I would say inlining undoes your all clever optimizations or generalizations or all your modulation of the code, factoring in different functions, so maybe reused later. And the inlining undoes all that, and you have something you would wrote as efficient.
There's a. All right, fine. That was a different comment. I thought you were going in a different direction there in the question.
So what is interesting about inlining? So our reliance on inlining, it's a consequence on the fact that we inline on intra-procedural optimizations a lot. So in order to optimize the code, we need to bring everything together into one function so we can optimize it using intra-procedural optimizations. In theory, I think if we, like there is a different design choice where we rely heavily in IPO, and we can do many of these things without actually inlining things together into one function. But I think many, if not like most compilers today, they rely on intra-procedural optimizations more. And that is why inlining is so important.
Okay, so there's some history here. Like IBM tried what you just said a lot back in the 70s and 80s. And one of the things that happens here is that you absolutely want to clone code to be type specific in particular places. So if you fail to inline, you lose precision that is entirely useful for performance reasons. Once you've inlined to get the precision up, because on this path, this argument is null, on that path, this argument is a constant, just exactly things you're inlining for. Here we can get rid of escape analysis, get all this precision for. What's left over isn't so helpful anymore to have massive, interprocedural optimizations floating around, so that I can tell something about the context of this method. He'll never get called with the arguments are nil or not the nil or whatever. It didn't help so much anymore.
Oh, but you can do specialization without inlining. So it's an effect. Specialization is effect of inlining because you create a specialized copy for the call side. But in theory, you can create a specialized copy just on the side and call it as a regular call.
Yes.
Specialization at runtime or at compile time?
No, at compile time, which you can blend with runtime here.
Mm-hmm.
Yeah, but that's not what I'm saying per se. If you've specialized, you've made the version you call the specialized, that's great. But you didn't necessarily win over the specialized copy that you also inlined, unless you, shit, sorry. The house things. Hey, I'm on the call. Well, coffee club.
There was a question in the chat about getters and setters. So we don't identify them by names or bytecodes. We just look at the cost of them, or cost of functions, and if they are small, they will be inlined, and they will be inlined into candidates as well.
So the cost boils down to a number, or how do you represent the cost?
Yeah, it's a number. Like it doesn't have a physical meaning, but that's just a measure of how.
You can imagine the cost being the execution cost in clock cycles, although that's not really what it is, but you can pretend that it's close enough.
Yeah. Essentially, it should boil down to a number to make the decision.
it's time.
The traditional way of doing it is that you assign a certain weight to every IR instruction or every assembly instruction if you're working at a low level.
Yeah.
And then you simply go through and you add them up, and then that's your number. And if it falls below a certain threshold, you inline it, and if it doesn't, you don't.
Right.
Yeah.
So in the land of Java bytecode heuristics for C2, we counted bytecodes.
This reminded me of the chess engines, how they compute. They just compute the numbers of the figures and
Yeah.
what to move and what to sacrifice.
Yep.
So is there a case for outlining to say, hey, I did a bunch of inlining and I did a bunch of optimization, and now I'm seeing the same relatively large chunk of code in 37 different places. Maybe I should pull that out into a function and replace it with the call that makes my binary smaller.
So Haim, I'll get to your answer in a second. It's really easy. But for Aaron, there are two things here. If you're doing small embedded systems, outlining is a major optimization because it reduces code size. And code size reduction both lets you fit it into the tiny little chip, but also it generally reduces energy because more things fit in your cache, and maybe you don't have a real memory hierarchy, you just have a wad of small fixed memory with no virtual nothing. And then it fit or it didn't, or it got paged out manually or whatever, you had energy savings for that. So that's always been a thing. Once your processors got sort of big enough and heavyweight enough, it became less exciting to outline, although technically iCache blowout still happens. There are a bunch of the heuristics for inlining that deal with the hotspot, and I know with other compilers as well, look for iCache blowout as a problem and try to resolve it. So iCache blowout happens because you inlined everybody on all paths, and you got a bunch of big methods. Like you have a complicated.
Can you count iCache blowout at runtime and change your behavior?
You make an approximation. So here's what hotspot did, and I've done it another way in a different compiler. But for the hotspot, the observation is that I have a bunch of medium hot methods calling medium hot methods that are all medium hot size. If everyone inlines everybody, you get an exponential code growth, and that'll blow you out. So at some point you say, this thing that I have a function call to that I can resolve statically, I could inline, it itself has been jitted into a large enough method that were I to inline it here, I would roughly get the same wad of code size duplicated again. Okay, and that rough wad of code size duplication would add so much extra overhead to the iCache that at some point we decide that's going to be a loser. So there's totally heuristic that says, if the thing I'm calling can be inlined, but it itself is a large inline target, I will stop inlining unless I have some other reason that overrides, where the goal is don't have every possible combination of function head plus his tree of inlines for every possible call site in that entire hierarchy, or you'll just have replicated JITted code, all specialized for each site, but with only modest profit for each specialization.
So the outlining tended to be less useful than just deciding when to stop inlining.
Yeah, that's correct. We just stop inlining. So the exception would be you had a hot loop, you had a profile data says loop is hot, I'll go ahead and inline in here. But if you didn't have something that said I have extremely hot profile data floating around, then instead I would go to a heuristic that said, it's kind of big, it's JITted already, and at some point, I'm not going to profit more than I'm going to blow up my iCache, so I'll just not inline.
And actually, the reason for this, that decision not to inline is more important than outlining, is a consequence of that our programs are already split into small methods. So we don't need to go long ways implementing outlining. We can just stop inlining because we already have these boundaries set.
Yeah, but if you have too many of them, the inlining just undoes that break of the code to gain more performance.
Say it again.
If you have too many of these small functions, then it becomes too much of function calls, and that's hurt performance of the code.
It's too much of the medium size after inlining. So like Haim says, how do you spot a getter or setter? Well, it's not by name because people call these things what the hell they call them. It's by the bytecode contents in the case of Java. It's by looking at the body. The body looks like load a field and return. the call and the call return and the prologue and the epilogue and blah, blah, blah add up way more than just the load, which will be
Because
one op, or it'll be common sub-expression and be half an op or a quarter of an op because it'll be shared amongst many getters being inline.
Yeah.
So you always inline getters like 100%
Because it's
because
small.
it's actually a reduction.
Because the code is too small and doesn't deserve
small,
to be
and-
a null
and-
function.
In the end, you'll probably actually have less generated code rather than more.
Hmm.
So this works until the method you're inlining starts to grow, and then you started making more and more copies, and you got more and more code. Maybe it includes a null check with a field load. That's really common, and of course the bytecode expansion includes one already. Those actually also probably fold right up too. So I don't care if I see a user written null check. I already got a bytecode null check. That's free. I'll throw it in. You started doing other math. We gave a arbitrary count of like 6 bytecodes or less. We would just inline, irregardless. I guess the only one we didn't there, we actually had to watch the recursion count. If you called yourself recursively, the compiler would die inlining infinitely itself.
Interesting that we, at this point, don't use that heuristic that you described, that if the method was already compiled into like medium-sized method. The reason is it introduces non-determinism that in performance that depends on compilation order.
Yeah.
And it saves a couple % of compile time for us. So
it's not compile time savings that I'm interested in.
So you're saying that it improves some performance for you?
Yes, because you get iCache blowout. If you're not careful and you have other heuristics in play that are maybe saving you from iCache blowout, I don't know.
Yeah, it's very possible that because we have different heuristics and different trade-offs, we just don't see this exactly.
So the way Hotspot would do is he would start with somebody blew out a counter at the 10,000 count mark. You would then crawl the stack looking for a root method to begin inlining, to begin as a compilation unit and then inline into. Because the guy you blew out on was probably a getter, and there's no point in
An interesting point would be if you have a compile time, your ID, or to tell you what will get probably inline. To tie back to our earlier last conversation with Darren, to tell you what would be probably inline, what would not be probably inline.
Okay, that's the whole thing of whether you trust a programmer to put inline annotations or not. And the lessons learned from C and for register and inline keywords is that's good for like 5 or 10 years, and then the technology catches up and it's no good after that.
The problem
the problem is trusting them to remove them when they're no longer necessary.
And they don't remove them, so you just don't honor them. And then what the hell do you have in the language for in the first place?
Yeah, and also because at least for us and for Hotspot, because things are so dynamic, the decision to inline or not can be dependent on many different factors like the profile, the state of the class hierarchy, the context you came there with. So
yeah,
it's
but
really
I would say you can, for 60% of the times, you can guess what would be inline probably with a very high percentage.
The problem is you have to put down a heuristic for inline. You have to add an inline heuristic that the JIT's just not going to do already, or it didn't help anything, right? So, you're just like, find a spot where the JIT loses the inlining decision and you get it right. And that's just this vanishingly small overlap period for most people most of the time. And for me personally, I just write my code where the JIT will get it right. If I know I need inline here, I will restructure so the JIT will just get it right. And that's easy. Just make sure you don't have a deep inlining hierarchy and it's always hot loops, must inline. You just make it all obvious. Here's the loop code, has these calls. The JIT, like nothing else is going on around it. You get them all out of a different method.
Yeah. It would be beneficial to do ID to say, oh, here is your call stack. He would probably the distribution that would be get in line, that would get in line here, and these call graphs would get a rough estimate of the call graph.
I'm almost less interested in me talking to the compiler as the other way around.
Of course.
If there was something that was both detected as hot and couldn't be inlined, and it goes, oh man, you have a super hot thing that I was unable to inline.
You have the
I kind of want the
JVM
runtime to tell me that information back and be like, by the way, here's where your pain is,
The
in
JVM
case you're
totally
interested.
says that. the inlining, but the met was hot and not inline. So the JVM would say if you ask it.
Oh
to
yeah,
do
I don't know
that.
how to write that error that says this is
I
the reason why you
I
were unable
totally
to get
disagree,
inline.
Aaron. I totally disagree.
Why?
Why would you ever want to know that?
One of my most fun.
I can't believe I
popular
believed you for a
experiments
second.
Was the
No,
you
no,
know,
no, like, no,
profiling.
so what a compiler does, so you've got 10, Arthur, help me out if I'm wrong on this. You got 10 levels of stuff, right? And it started inlining like up here somewhere, and it got too big of a chunk, and it's like, no, I'm not going to inline anymore, right?
Mhm.
So the compiler has to look at that and say, oh, I'm hot, I got to start inlining from the bottom up, because your nested iteration explosion calls. So if I inline from the bottom up, I might have 10,000 calls for the internally from this point down. But if I inline from the top down, I might have 400 billion calls. And it's because if each level is a, for I equals 1 to 100 call, for I equals 1 to 100 call, etc. By inlining from the bottom up, you
want help here?
Huh?
You want help
Yeah.
here?
Explain it.
This is the whole point of profiling data. So when somebody in the land of hotspot said, I blew out the counter, it's time to JIT something, we
Right.
crawl the stack looking for a large change in execution frequency. If you're at the 10,000 mark and the guy above you is at the 9999 mark and the guy above him is at the 9900 mark and the guy above him is at the 9,000 mark, we're still crawling the stack because you guys are all calling each other almost surely. And at some point, we suddenly got a guy who's got a 10 count. And we're like, wait, you probably made a 4100 loop around this set of dudes. That's our starting point.
So this part of compilation policy, as far as I know, it doesn't exist in Hotspot anymore, and we don't use it either.
Oh, I bet you it still does.
And I don't remember much history on this decision, but I think the problem is because the moment when you overflow the counter, you have only one particular call chain that reaches this call.
That's correct.
And it can be different. Like it's just a luck what you would.
That's correct.
To compile if you do this walk.
That's correct. So here's the trick with that luck though. If you missed and you got the wrong one, you're going to blow it out again on the right one really quickly with high probability because the hot one is hot, and the odds are really good you get the hot one, not the miss. But you occasionally get the miss. It happens.
Well, I think it might work if your final tier compiler is relatively cheap. For us, it is probably too expensive to compile many different colors in hopes to find the right one at some point.
It's not many. That's what I'm saying. 99% of the time, you'll get the right one. 1% of the time, you had to compile twice with one miss. You get the right one according to the frequency of how right that chain is.
Well, but let's say there is some method that is being called from 10 different colors.
Yeah.
You overflowed one particular stack trace, you walk up, you choose one of these 10 colors, you compile it.
Right.
Then
that dude you didn't JIT because you JITted the guy above, he's still getting counted on. Whether it's the C1 or the interpreter, they're both still counting away on him. So he overflows again on a different call chain. So you crawl the stack again, you get a different guy.
Eventually, you would find all 10 of them and you would compile all 10 of them without compiling these one method. I'm not sure that this is the best decision because you may compile this one method, maybe it won't be as good as compiling the caller, but if you compile and install this one method, you improve the warm-up characteristic. And
so that's the difference between C1 and C2. So C1 doesn't go crawl up the stack very far. He quits right away. So he wants to get this guy that you just said was hot, and maybe he wants to go 1, maybe 2. He's looking for very sharp cutoffs. As soon as he gets a little bit of a fuzzy cutoff or gets not very far, he just quits and says, I don't want to make lots and lots and lots of copies of the wrong dude. I'm just done. I'm going to take this path and wrap this guy up. And then I'm going to continue profiling on him. And C2 may get several, compilations according to whoever's hot or whoever's not, but you know, you can get the wrong guy C2 once or twice, but most of the time you're going to be in C1 right away. The flip from interpreted to C1 is the 10,000 count. Now it's 1,000 count. I think at the end of it, 1,000. It's not very long, and then they don't crawl the stack, so you don't get very many misses. They don't.
But what is the
stack
count for
very
C1 that's much less than 10,000?
Yeah, I want to say C1 ended up they started out at 100, and I think that got moved to 1,000 at some point.
I think it's 1,000.
I know
Okay.
Node does its first compile of something once it's executed the third time.
So this is like a stage 0 versus interpreted kind of thing. You can do it at that count. C1's definitely heavier than a template jet. It's an official first tier compiler with a linear scan allocator. It's not a template jet.
Almost
they
makes
do
me
call
wonder
this-
if there should be more tiers. This
Well,
is the one I trip at 3. This is
yeah.
the one I trip at 3,000. This is the one I trip at 30,000.
Yeah, you can imagine that. It's hard to get all the transitions to be monotonically performance improving is part of your issue. Like you can screw it up and then have somebody fail to compile and come back around, or get locked into a C1 compile when you need to be in a C2, or you generate butt tons of code for every different compilation level and you have your iCache blowout and the like. So you know, it's like register allocators. There's a lot of heuristics, a lot of ways to do it. I did it a particular way. It worked out really well. Arthur's doing it a particular different way. It's probably working really well for him. I can't say his is right and mine's wrong, or vice versa. They're just different ways to go at this problem, and just be aware. He's got a slower final tier compiler. He wants to make fewer final tier compilations than I did. Now, my final tier compilation was probably 10 times faster than the LLVM and 10 times slower than C1, right? So, you know, where we make our final tier and the relative costs of them are different. I was okay throwing away a few compiles. I also put them all on a background compiler thread, so extra cores were getting. That was another way to cost reduce the cost of a missed compiler.
So it sounds to me like, Cliff, you're not particularly worried about non-determinism and that it might get a slightly different compile each
No,
time.
I wanted to cover
Arthur
that.
does seem to be worried
I wanted
about
to talk about
non-determinism.
that, and we got side directed. And I actually want to get back to Haim's question as well, because he had another one that's interesting, but we'll get there. So yes, the non-determinism can be an issue. And I don't know that Arthur's dodged it any better than I did. He moved the needle where it is, but I don't claim it's not there either.
Yeah, it's still there. It's just that this was one of the reasons of this kind of behavior.
You were hoping to make it less non-deterministic.
Yep.
Yeah. So we would have, like for many years, there was a known tension between people doing stupid micro benchmarks and the sort of well understood way to get a proper benchmark performance numbers out of a JVM. It's called the compilation plan. And you didn't know what the compilation plan was, but you could get a different one. And there would be, in fact, a set of them, and they would show with different frequencies. So you had to start the JVM from scratch. It was not sufficient to call the micro code a different number of times because the compilation plan got nailed down. It did not change. So non-deterministically, according to where the stack crawl hit and where the network packets showed up and where the allocation gave you things that your hash code reprobed or what, fucking everything was different. So you got a different compilation plan based on the frequencies of the moment, based on the profile data of the moment. Sometimes the compilation plan it was more or less performant than another one, and that was really only a problem for micro benchmarks, where they were really desperately looking for how exactly you got the x86 machine code instructions for this tiny piece of code, which a little bit left and a little bit right would give you big numbers in performance. So it's like an electron microscope. You zoomed in on the gnat on the hair on the wart of the fly on the tail of the elephant, and God knows what you were looking at, but you zoomed it up super big and the timing performance numbers. And was this exciting when you ran the elephant? Maybe not. But you could say right here, right now, when I'm computing Mandelbrot's in a tight loop, sometimes I inline this way and sometimes I inline that way, and there were 30% numbers. And so you fucked up, sir. You have a wrong answer or whatever. I hate you. And you get all these flaming comments out of people. And the answer was, well, try it 10 times, 9 times out of 10, you got the good number, 1 out of 10, you got the bad number. And none of the things I would do to change that number would have any impact on running the elephant, right? The elephant was this giant thing with performances all over the map. 5% hacks in the register allocator would reliably speed up the elephant 5%. All your little minor inlining heuristic, left, right, up, down, or register allocation for exactly the loop thing, whatever, that would not touch the elephant at all. Register allocation, speed up the elephant. Loop hacks, once you got the basics done, not really help the elephant anymore. Micro benchmark numbers claiming you should have inline left versus right never would touch the elephant.
Well, the problem is when you have an inlining heuristic that failed to recognize some benefit, but if you decide to inline it, you get this benefit. But if you have this heuristic that says do not inline if there is an installed version of this method, you can lose performance because you just didn't recognize that there is a benefit.
Yeah.
So there are situations where it introduces meaningful difference in performance, even in non-micro benchmark setting.
Go look up papers on Java compilation plan. There's some really good examples that show up in the papers of where and why. Let's see if I can go Google-late some things out. You're absolutely right, and there are micro benchmarking. Let me try to, okay.
So should we pop the stack and get back to the questions from chat?
Yeah, I can handle Heems really easily. It's just you have to go keep that data around. So I've found the JMH benchmark, but I don't know if it's going to have a discussion about where you would fail. Back in the day when people were first fighting it, discovering this was going on, I had this micro benchmark wars for about 15 years. I stood in front of audiences and said, you're doing it wrong, before people started doing it right. Then JMH came out a couple of years later and people mostly got it right now. Yeah, hey, it's a data management, data structure problem. At the time that I am parsing bytecodes, I track the virtual machine, the Java virtual machine's execution state. So conceptually, I know what you had in Java local 1, 2, 3 and Java stack element, blah, 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 and where you made the calls. When I came to an inlining, I would take the data I had in the current call and like push it on an internal stack and add the next layer in the stack and lather, rinse, repeat. So I'd have a list of, if I went 10 deep, I had a list of 10 calls at what bytecode index, the locals were the following things. That mapping pointed back to the IR I'm generating. And I hung on to the map and I called it a safe point. Then I jit the code and the safe point is just another piece of IR pointing to the semantic equivalent expansion of the bytecodes in the IR. And when it comes time to go generate code at every place a safe point would be like a leaf call. In this particular method, I ended up calling off to there, but I inlined 5 times in here before I went off to that call. So at that call site, I associate a map that said, here's where the Java virtual machine state was from the IR. Well, that went through the register allocator. So that went to physical registers and stack slots. So the map said from, you'll find Java local 7 in physical register RAX and Java local 10 in stack slot offset +8 from base of stack or whatever it's going to be. So that information is set to the side. We would call those an OOP map or a GC map, where the OOP map was actually the Java execution state map, and GCs just had what things were garbage collected pointers and what weren't. So the OOP maps carried more information than just GC maps, but you in theory could have both. And they're just set off to the side, so no program executes them. But the garbage collector will stare at them. And if you deopt and you have to blow out and rebuild an interpreted version of your JITted frame, you would, in fact, read that information.
Thanks. So basically, it's possible when I'm grabbing a stack trace or creating a thread dump to know which method are inlined, right?
No, but you could. I mean, the JVM will not tell you that information. The JVM, however, totally knows that information.
Yeah. So theoretically, we could implement to change the thread dump to include information.
Profile.
Yeah.
The profiling tool that I wrote at Azul that was called Zing at some point, and I assume it's still available, gives you that information. Or it did give it to you at that time. You could get stack traces that included the inlining depths. You could get the generated code plus all inlines, plus all the what the compiler knew at the time, the inline and shit. I don't know where Arthur's with LLVM on the generated code size, but the stack traces were totally available.
Okay, thanks.
Yeah, yeah.
Is the tool from Chris Newland still around, by the way?
The tool what?
From Chris Newland?
What was the tool called? There was tools.
I actually don't remember. That's the problem. The inline viewer that actually analyzed all the inlining logs and stuff.
You could ask with extra -XX flags for the inlining decisions made for everything. So plus print compilation would tell you one line per thing that got compiled. And then there was a XX plus print inlining or whatever. I don't remember what the names were, and they changed actually over time. Would also tell you JITwatch. Oh, surely JITwatch is still around. That was, people got popular on that one.
It takes the logs and just visualizes them nicely.
Right.
Right, but you add XX flags to get the logs. Yeah, and then yeah. Here, go Google like JITwatch. Boom, pops right up.
Got it. Got it.
Yeah.
Okay.
Yeah. So what it won't tell you is why something got inlined or why it did not.
But
Usually
it tells you that it did not get inlined, that it actually failed to inline.
yeah, but does it tell you
I've
why?
seen in the log, the method too big failed to inline, method too big needs to.
Does it tell you why it didn't inline?
I think it only has like method too big or something.
Well, that's what it says in the inline tree you get when you have print inlining.
Because sometimes it's not inline because I couldn't devirtualize it. And sometimes it's not inline because it's too cold. Sometimes it's not inline because it's middling cool to a large JITted method. Sometimes it's, you know, not inline because it's just too big for the current compilation unit. So there's layers of why I didn't inline you. Sometimes I got down to, I'm doing a devirtualization of a limited count target method, like say NIO, direct buffers versus heap buffers. And I had instance of you for direct and inline the direct, and instance of you for the heap and inline the heap. And then I didn't have the third path, and that was just going to be a vcall if you extended with another unrelated NIO byte buffer and the like. So a bunch of reasons that generally depended on localized information. Like at the time I JITted the code, I could see multiple targets. At the time the code's running for a long period of time, one thing is very hot. At the time I JITted, it was not one thing very hot. So at the time I JITted, I said, no hot target, I'm not inlining anything, you got to be called. Later on, after you ran a while, you had a hot target, but I didn't rejit for whatever reason, because I didn't rejit. If I had rejitted, I would have said, one hot target, I'm inlining it, and all the rest go to vcall. And so, you know, there's a lot of heuristic rules you could imagine trying to explain to an end user, and you're changing them constantly. So it's a little bit of a delicate process. These days, it's probably a lot more stable and make more sense to print that out. And you could argue, I want to force a rejit because I know I'm going through a phase shift or whatever. Like when I left Sun, I was not well supporting phase shifts. By default, when you phase shifted, you frequently forced things to rejit because the phase shift brought in new classes, new methods, new things that hadn't been seen, whatever. And that got you the win for the phase shift rejit. But it was not a thing I looked at. So if you had a long running phase shift between two different phases and you went back and forth, you ended up with the mediocre plan that handled them both, but you didn't get the good plan for each independent phase shift.
Okay, I think we finish it inlining
We beat it to death.
in the register allocation.
We didn't beat register allocation to death, but we can declare it. So I got some obvious non-register allocation people in the audience
It's
here.
interesting to see because we periodically turn back to something we have spoken in the previous, and it becomes more clear and more clear what everyone idea is, and it's interesting to see these concepts evolve through Friday from Friday.
Okay.
And what is interesting for me, for example, is that, yeah, we are working on tuning inliner stuff. And Cliff did this like 15 years ago, and he was also working on inlining. Like, and you talk to people who worked on in this area before, and the major subjects are still the same. It's just our understanding of how things work got better. Like, we improve in some aspects, but the main topics are still the same.
The
Yeah.
idea,
If you
the
took an
brand
image recognition person from the 70s and dropped them in the world now, they would be totally obsolete. If you take a compiler person from the 70s and jump them forward 50 years, they'd be like, oh yeah, I recognize all this. Yeah, but you were here for the whole 50 years. You didn't just rip back into it.
I did my first compiler when I was 15. So not quite 50 yet, but in 5 years, I'll be 50 years writing compilers.
Well,
So does anyone mind if I change the topic entirely?
Yeah, shifting gears.
I was curious what people think about import statements and export statements. And as I'm pulling in code, should I have the sort of one symbol comes in from every time I call import? Or do I want to allow the like import star from this file and I get a bunch of stuff and I have no idea what symbols came in, which makes it hard to read the code because now I've got some symbol that got defined somewhere.
Well, first of all, it's important to discriminate between import and import. So different languages.
Yeah, so I dropped my snippet of what I think AA importing will look like in the doc.
Oh, nice.
Which you can feel free to correct me if you're like, no, that's not at all what I was thinking.
Oh, you're doing black on whatever. Yeah, math will just come in by default probably. But we could.
So that's part of my question is one of the options is to say, there is an AA file that runs before your code ever gets started, and it populates the environment with a bunch of stuff. And the other one is to say, oh, the top line of every AA program is going to be
import.
This import.AA core, and what comes in with AA core is like ifs and for loops and or and all the stuff that you expect to be there, but that's not technically part of the language. It's part of the standard library.
Let me hit the share button here.
Because it sounded like even for was not going to be part of your language. It was going to be part of your standard library.
But where is sys coming from if you don't have default imports?
So the top level has a namespace, which in right now I have like math, which is just a struct. So you say math.sign or math.cosine, and gives you the field sign, which happens to be a function that takes a float to a float, does a sign thing, the obvious thing. So now the question is, should I remove some things? And then you need to have one top level name, whether that's import or sys, you need to have some top level name to get you going. Right.
Yeah, I like the idea of sys and being like the language itself claimed one symbol. You get all the rest, and everything else is only defined if you define it.
Yes. So then I could argue, yeah, sys.import of math and sys. Whatever of however it's going to be. I don't know. And then, you know, I'm with you on this, that I'm kind of back and forth. How many symbols do I want to take up front? Like I can't use the word package for my Java class at the beginning, because package is how you name a package in Java. So what symbols do you want to grab up front? If you look at Python, they totally import is you ran some code and that was the import. If you look at Java, the import is a stateless description or stateful description of how things, but no code is executed. And I'm kind of in the Python zone of I'm going to run the code. And if the first thing the code says is sys.import, then you're going to get something.
Yeah, I know we talked about earlier the question of, can export simply be the last thing that's in the file? So if I'm executing it top down, and the last thing that's in there is just a struct that's got named things in it,
that's the export.
That's the export, is just whatever was last.
That could be.
And then you don't have to like have a keyword for export.
Right. I'm watching somebody write no dynamism and they say import. So you immediately stole the word import. Oh, here you go. So you stole the top level import word as opposed to top level sys. But that's fine. This is an open question for me as far as I'm concerned. I'm like trying to sort out what's the right thing. By the way, I did get the core theory working with my evil evil union null unions. So I'm back onto the main AA code base, sorting that out. So what's JavaScript's bug here? So I don't like the second guy you gave because I like having the string. But what's the auto completion nightmare? I know putting strings in that are dynamic has difficulties in recognizing what are the modules. So if you want to build tooling around having multiple modules, you have issues there. Why is that an auto completion nightmare? I don't like the third line in there, but why is that an auto completion nightmare?
So I wrote the counter example, and it's basically it's the same problem when you write SQL and you have to select before the from, and it's much easier for the ITE to give you good suggestions if you tell the IDE the rough area you are looking into. So if you say AA.core, it can give you all the things that are in AA.core. But if you write random things, it has to look everywhere, and that's not as accurate and not as efficient.
I see.
And the results might be like very slow because it can't constrain the scope.
That what your issue here is you're writing the code in the wrong order. You should write this is equal to import of quote AA core blah blah blah, and then you go back to the start of the line and you say sign comma coast comma blah blah blah, and those things I actually get from the local method because they're going to get defined. I look for undefined names in local method. I would like the IDE to look for undefined names in the local code. In the list of imports, I'll write the import up front, and then I'll add in, oh, I want to import sine and cosine, but not all of math for whatever reason.
Right, unless you add a dot at the end of that list that says, oh yeah, and give me everything that's in the package.
Yeah, then there's some way, right, in some way to say, give me all, yeah.
I wouldn't support these star imports at all. I mean, if you look in most popular languages, all the IDEs have lints against using star imports.
Yeah.
And I think it's also a question of like of design purity to say, okay,
my answer is sort of both. I want to have that import dot, but the minute I save it and run the auto formatter, it should say, oh, you used this symbol in your code somewhere.
Yeah,
I am going to put it in the list at the top for you because that's where it came from.
Right.
To be honest, I might have used too much Go in the past or in the recent past, but I actually like how they do it. You basically just import the package or the module, and in
they're pretty aggressively. You get one symbol from each import, right?
Something. Sorry.
They very aggressively are like you get exactly one symbol from each call to import.
Not really. So the way it works is in case of AA core or whatever, it would be core dot something. So you basically always have to give the module name, and then you can call the function. That way you automatically get this separation if you have like two max functions or something.
Right.
So if you have a second min or a second sin or whatever function, no, not
right. No, you're talking like at the use site. Let me go add in here. Uses. It's either math dot costs.
Right.
Is costs,
Right. And if you have two modules with the same name, you can give them an alias at import time.
Well, right. And so one of them is more typing at the use site, and one is less, and one is more explicit at the use site, and one is less. Elm would say that you could get away with no saying the leading module name, no math dot, as long as it was unambiguous. As soon as you were ambiguous, you could not declare a winner. You must specifically name at all places now. So I had two different kinds of max. I had to say float.max and int.max everywhere. I had max. I couldn't.
But why not fail at the import already if you're importing
because I have,
ambiguous
right,
things.
I have a bunch of things that have opens because they need setup and teardown in the same piece of code. So I need a db.open close, I need a file.open close, I need a transaction.open close, all in the same piece of code.
Yeah, I mean, then your import, or then the compiler will allow you one import of close, and that's it. And if you want to have another close, you have to either qualify it or rename it.
Okay,
I
so I would claim that I don't want to rename it because I want it to always be, transaction.close versus not. Let me go down a code block here and say, give the example here. So somewhere in the world, I'm saying sys.import, and let's say, DB, and there's something I don't know what I'm going to do here with. So let's do the wildcard horrific thing because that'll be the bad case. I have a transaction, and then in my uses somewhere down here, I want to say I have an open call, and is it right?
Right. So the behavior I would like in that situation is if the same symbol appears in DB file and transaction, that's fine until you put it into the file. And now that you've actually used that symbol, it says, whoa, this symbol could have come from 2 or 3 different imports.
Yeah.
You better actually put that in one of the 3 lists, because otherwise.
Oh, I see what you're saying. So I'm currently looking at, would it be okay if at the use site, I just qualified it and it was illegal to have a bare open? It was okay to import 3 opens. It's illegal to use the ambiguous open. It is right. Not.
I would say if you wanted that, you should have said DB equals sys.import DB, as opposed to pull into my namespace everything that's inside DB.
Okay. So you're claiming that this pulls in a namespace, and how do I do this with a good syntax here? DB. Okay, you're doing the same thing. You do it first. We're stomping each other's feet. I'll quit typing. Right. Oh, just in general.
Yeah, if you want the whole symbol, import the struct. If you want to unpack the struct,
so that says
unpack
if
the
I
struct.
use any conflicting symbol, I have to have them all under DB dot everywhere. So DB dot query, which is a different guy, can't be done. So that says that query of squeal string here, no query defined, and instead it's db.query, although file and xtn don't have query.
Right. Whereas if you say open, it's going to say, hey, both file and xtn have an open in them. You have an ambiguous import.
And blow it out right there.
You better either put file in one of these lists, put open in one of these lists, or you better replace that and say, I'm going to import the whole thing with one name, as opposed to.
If you put open in that list and under XTN, you also put open in that list, I'm going to claim you're just shadowed, and I'll give you either a shadowing error, or I'll just say, it's okay to shadow. You're just shooting yourself in the foot, but okay, shadow away.
Yeah, I would say no silent ambiguous shadowing, but if you put it in somewhere, if you actually put open in 2 different lists, then yes, you shadowed and you asked for it. And now the order of your imports matter.
I think actually right now I disallow same scope shadowing, period, end of statement. You have to add a scope, curly braces, or I would just say, you got 2 opens. Nope.
Yeah.
I will say though, if I want to shadow, I better do that.
Yeah, I'm going to say if you want to shadow, you have to add a scope, and that's how you let it pass. So whatever. That's legal. I'm okay with where we're at here. This is basically saying I can use dot syntax as long as there's no ambiguity. As soon as I have any ambiguity on symbols, even on symbols, I'm not. Oh, I see. No, and I'm still can allow ambiguity if I never use the ambiguous symbol.
Yeah,
Right. As long as you don't use it, it's not ambiguous. You don't care.
But if I use the ambiguous symbol, I have to change the import syntax to give it a name.
Yeah.
And now I have to use a dot notation on all DB things because I didn't actually import all of the DBs into the local namespace.
Yeah.
I only imported them into the DB object, which has its own internal
implemented
namespace.
shadowing for sure.
Yeah, and I don't like, oh, you can rename individually that way. Yeah, that's okay. Under the XTN, the open keyword is only available as the namespace you got from the result of sys import, which brings you a struct that has an open field, which you then renamed on the spot. And yeah, I'm not certain I like that syntax. I understand what you're doing there. In practice, when I've seen that happen, I hated it. I would rather have sent xtn.open and force you to been explicit. Because as soon as people renamed the imported name to their own private name in that file, I had trouble remembering what was your private version of the name for what I knew what XTN had in open and where the hell did it go? So I don't like this one. That's my
I think
personal
it's
thing.
generally a better practice to just say import XTN.
Yeah, so I'm not saying it won't happen that way, but that's my personal preferences. Like,
Well, so just the general thing. The stuff on the left of the equal sign is just structural unpacking.
just structural unpacking. That's all good. So this
There's
is
nothing special about that. So
yeah.
do you not want to have renaming as you're doing structural unpacking? Because I feel like that's going to come up a lot.
yeah. It's in general, I don't like that per se. This is actually structural. The other one is not a structural unpack. Just structural copy.
Or destructuring. I don't know if those are the same thing or not.
Yeah, right. That's a different preference. And it obviously plays into imports, but I would be consistent either way. Either I'm disallowed or allow it.
If we talk about consistency, I think it should always be just a structure copy.
Well, structure unpack is a useful thing. So I want to allow structural unpack. As soon as I allow it as a general rule, I'm returning a tuple. I'm returning you an OK fail and an error string or the thing. So I'm returning you a tuple and you're going to unpack it, right? Whatever. There's a lot of reasons to return tuples and unpack them. Okay, fine. Now that I'm doing that, I don't stop it because I got an import object. The import is just returns me a structure. Now I can structure unpack it. Why not?
Right, but I think that goes back to the earlier discussion. It was not a radio discussion. Is it just like a declarative thing that doesn't execute any code, or is it actually code execution? Because then it would be structural unpacking.
Right. And so where I'm at right now is that I'm going to be ambiguously identical to code execution and structural unpacking, code execution and declarative. So we could argue that no, it must be declarative. Java's declarative, Python's execution, right? And then claim for execution, for it to actually work in a large module system, you have to have some sort of well-defined behavior because the module guys don't do execution, they do structural. And now should I switch to a structural model for your namespace? I'm sorry. Yeah, a declarative model. Sorry, declarative model for your namespace. I can do this with execution, same as Python. I kind of like it. Is that a bad plan or a good plan? You know,
It's great for a single core machine with no multi-threading. So
why?
I think,
What does multi-thread have shit to do with Shinola here?
well, I mean, that's why Python can never be multi-threaded.
Yeah, no. Python can't be multi-threaded for other mistakes. I don't understand
Global
why.
interpreter lock. That's
Yeah, but that has nothing to do with system import.
That's a minor, the global interpreter lock is a minor implementation detail compared to the fact that the order in which things are executed defines the system at its present state. So if you believe in a deterministic universe, no chaos, no randomness, like we're a single threaded universe and one thing happens at a time and we just happen to see it in really fast motion, or Java or C, or you can't have both. I mean, if you want the code to define itself on the fly, it becomes a single threaded system or it becomes absolute disaster. So the Python model doesn't work. I mean, give me one case where it does. Like, give me one case where that works in a concurrent system. I can't think of any.
Concurrency, I'll say concurrency is like unrelated here, because you can certainly write C programs that are concurrent. Well, the JVM itself is a big ass C program that's concurrent.
That's exactly my point. I'm saying C, Java, all these are concurrent because they're not allowing the code to redefine itself on the fly as it executes.
Redefine the namespaces on the fly. I mean, Java does with class
namespaces are compiler. Namespaces are compile time. So forget that. I'm talking about actual, the way Python actually shapes the entire universe as it executes. You can't have two threads doing that at once, or it doesn't work.
I don't understand why you say that, because it obviously seems to me it totally works. I don't understand what the conflict is. So give me a counterexample where there's an ambiguity conflict here. There is certainly a data race that you have to sort out with data races, like every other concurrent program has to sort out data races.
Can you show me a multi-threaded Python?
That's because Python has the global interpreter lock and implementation.
No, a particular Python implementation has a GIL.
I mean, there's
Python
certainly
does not.
multi-threaded Lisps, and they rewrite the world.
And I know Python runs, there are multi-threaded attempts at Python that are not falling over this problem you're talking about. Up front, they do whatever the hell the Python import thing is, and they execute it and go to town in this piece of code, and the next guy who calls goes to town on that piece, and it doesn't, they're unrelated. I don't understand what concurrency would break Python. I don't understand why concurrency would break a Python that ignoring the GIL.
Because it's not designed not to break. Okay.
No. That's
don't
not
understand the
an
question.
answer though. So if I run some code that says sys.import
you don't-
at the
But you
start,
don't have code unless you run code. That's the Python model. There is nothing
yes,
like that DEF word in Python says, hey, from now on, this thing will exist. And
Yes.
before that executes, it doesn't. And after it
Right.
executes, it does.
right. So if I want to have my multi-threaded code use the result of that def, it better launch its multi-threadedness after the def appears. That's a standard ordering problem.
Okay, so what you're saying is you could solve it by running single threaded most of the time and then open up once everything is fixed in the
It's just the same problem of managing global mutable state that you
Yes.
have in anything with global mutable state, isn't it?
I run a JVM, it starts up and begins executing, immediately kicking off threads. They all load classes out of order. There's a horrific locking going on under the hood in the JVM to do what's basically class for name on every class that's getting touched by all these different threads. So that the JVM exactly does this.
No,
Oh yeah, it
no,
does.
there's
I
a
think that-
difference between loading a DLL and the DLL writing itself as it loads.
I don't
I
understand
think
why
think
there's
the
you think there's a
different-
difference.
No, I think the difference is if you actually implement it as a function call, like sysimport, you actually have to execute stuff before you can build the tree.
Yeah, that's
Yes.
exactly what Python
With a
does. That's what I'm-
declarative,
Okay, that's exactly what the JVM does too. Whether you
No,
know it
but-
or not, under the hood, all those classes are basically class for naming at the first touch. And there are a bunch of rules about what it means to class for name a class. The next one, after he knows it exists at all, is you go do the load step and find all the things he touches nearby. He's basically running sys.imports at the class for name time. He doesn't claim the class exists yet, but the VM actually knows it does. And if multiple people go grab that class, eventually it just runs, it's single threaded during all the sys.imports. It's not multi-threaded there. Or if you like, the imports are all under the hood getting locked and single threaded until they finish out. But the rest of the system doesn't need to care about that ordering per se, unless you happen to write
but
a
that
bad
class
ordering.
is not defined by the execution of the code that was loaded. I mean, it's a fundamental difference. Like,
Well, yes and no. The class is totally defined by the order of how things come in, but you just don't. But the order is
no, but
specified in the
that's
list.
much more like when you're loading an SO and you've got
Okay.
an unresolved func that the first time you hit it, it's going to go and resolve everything
Here-
behind it.
Here's maybe the example or the lack of example that causes the issue. If I run all my imports at the start, I am doing essentially what Java does. But if I run an import in the middle, I'm running class for name in the middle. So if I put all my imports at the start and I say, this is all going to run single threaded until you get past the import section, and I have somebody tell you you're done with the import section, then I'm effectively running the Java model.
I still don't think
No.
that's.
No,
I'll
not at all,
claim
'cause
I
the
can do. I
Java-
claim
the
I can
Java
do a
model does
mapping
not-
that
But the
would
Java model
one to
does not
one.
run imports. That's what I was said in the first case, is like there are two ways to look at an import.
Yeah,
An import is a name resolution mechanism, or
Yes.
it's a code execution mechanism,
yes,
right?
Yes.
And we can pretend in the simple cases that there's no difference between those. But outside of the simple cases, it gets very ugly.
all right, let me,
Right.
let me kill
The
this.
win of an import being a wrapper around a val is that you can do arbitrary things at imports. The disadvantage of doing that is you can do arbitrary things at imports.
Right. So if you only do imports at the start and you agree that there was a single threaded locking on how those imports internally worked, they could be run out of order by a multi-threaded guy who's actually going to execute them in order, but there's a locking in the first one. So the second man in has to wait for the lock, and then he discovers it's already been imported, and so he's done. That would give you the Java model directly, because you didn't import anywhere else, and you had no choices on the imports, no dynamic runtime choices on the imports. If you had a test in there that said, I'm running some code that made a questionable, made a decision, but had a predicate it executed, then it imported left or right, now you have a different problem, and that's effectively the class for name issue. And that does fuck with how, what's a Java module guy do when he hits class for name? Well, they do the same thing JavaScript does, a whole ton of heuristics to try and guess how your class for name is going to be, but they don't always get it right. So you can argue, I'm willing to accept the argument that having a set of things up front that are declarative, whether they look like they could be run execution-wise or not is a separate issue. Having upfront declarative gives you a point at which you say, this is where the module system understands what things are. And anyone else that comes after this is a class for name, and the user has to understand what it means to class for name yourself. Right, so that your module system doesn't grok your class for names that show up later.
Yeah.
Now, having said that, I can make that work in an execution model identical to the module system up until the point where you run some other code than sys.imports. And any single
come again with
threaded
the last bit.
executionally. I'm sorry?
Come again with the last bit, unless you
run something that admits to changes under, in this case, in Cameron's case, under changes under a multi-threaded environment. Read something outside the file itself and makes a decision to import or not a different way. So one of the fun, fabulous grief you get out of Python and actually JavaScript is that people hack the import path because they're trying to find something, right? So if that hack touches something outside of the function of the file itself, then you have an issue where you can't tell from within the file what you're going to find. And Java doesn't let you do that. Well-structured Python doesn't do that, but you can write unstructured Python that does. And this is why hearing Cameron claim is an issue. But like my well-structured Python, we wrote Python AA, we wrote in there, semantically can be made equivalent to the Java model by simply having the right locks inside the import, which you surely need anyhow.
I think the other thing was when I came back, you said that the other problem is if you have imports code and then somewhere in between an import.
Yeah, and you import again. And what's that do? That's like a class for name game, right? So,
Right. But if you're in an environment with eval, you can't protect yourself from that. New code just shows up. That's the reality of the world.
that's the reality of it, yes. And now, do I want to have this? How does this work? Play with a module system? And do I want to declare I have a module system and these are the things you can module? And also you can class for name. And if you class for name, it didn't hit your module system. So I get unknown dependencies and shit like that.
The difference is class for name loads bytecode, understands the dependencies, can go ahead and load the dependencies before actually executing something.
Up until the next class for name that you loaded from the class for name. He can't get the dependencies from the recursive class for name. Same as eval can't get the dependencies from the recursive eval. But the first eval that you load could have all his imports at the top and I could execute them, or I could claim that they're structured well and therefore I'm using the declarative model, and those are semantically equivalent. I can arrange that you can't tell the difference between them by my implementation choice for import. Fine. But you still have the problem of the next class for name or the next eval came along, so you can't follow the dependency chain. So there is a version of goodness in the world that says, here's all the obvious modules being obvious, and I'm declarative that way. And we all know how to find all these. And I like class for name and I like eval. So new shit shows up. It's not in the module system at the time it shows up. So there's a separate issue now. What do I do with new shit? Do I ignore it in the module system's point of view? Do I demand that it fit nicely in some hierarchy in the module system? The module system is not the whole program, the closed universe model. It is an open universe model. I can keep adding new classes on the fly as I go. You know, Java went to the open universe model with a strong notion of what it meant to have modules up front, but I could class for name at every possible step and import shit for Chanel at the top, and he would run and it would be fine, but your modules would now be fucked. And that's what Python chose as the default. And then to reverse it, they said, and if you write them politely, we'll find them and your module system's back to working mostly up until you import something that you didn't talk about before. Same for JavaScript. But everyone loves class for name and everyone loves module systems. And these are like,
I'm just trying to figure out if in Java, it would be possible to force a situation where with a cyclic import, you actually have a partly constructed class state, whatever thingy.
Oh, Java totally lives in this partially constructed class state thingy. I had to do all those fucking semantics. So when you said I have a class, it goes through a series of steps where it is ever more partially alive. At any one of those steps, you can talk about another class, which recursively talks back to you or talks to somebody else, and then they bring some stuff in and then they come back to you again.
Yeah, you're right. You're right.
Yeah, I think there are better places to innovate a language than messing around with imports.
Well, there are two popular styles in the universe. There's the Python style, and then there's the Java C style. But the Python style can look like the Java style as long as you're polite with how you set up your imports. The Java style can look like the Python style if you start class for naming everything. Hey, I'm running Scala. Every fucking thing runs through a class for name because the Scala JIT took whatever the hell and he blew out miles and miles of Java methods, Java code, and class for named them all.
But there's certainly no C style. I think we can all agree on that. There's no style in header clouds.
C goes to the closed universe and you can't add new code. So the module system makes sense there.
Yeah, I think you should design for the majority use case, which is certainly static imports. The static imports, where you 99.9% of the time know exactly what you are importing from which place, and dynamic import or eval or class for name or whatever you want to call it, let that be a separate API cordoned off with warning signs and everything, with like reduced reliability, where it's completely clear if you're using import, you can rely on it that it 100% of the time does what it says on the tin. And for the weird use cases, there is this other thing. Good luck. And regarding the disambiguation rules mentioned earlier, I mean, it's a self-inflicted wound. Don't have star or dot imports, and 90% of the problems are gone, because if you start with the dot imports or star, whatever you would call it, then you probably want to have some intuitive disambiguation rules. And I mean, the last time I looked, for instance, in Scala, they have like 4 different levels of import precedence, because ending up with the intuitive rules that users expect when faced with star imports and qualified imports aren't so simple. I mean, in Scala, you first have a blanket import for java.lang. Then you have a blanket import for scala.lang. Then you have the package.scala file. Then you have the predef.scala file. And it's still not really consistent. For instance, double, if you type in double, it depends on whether you use it as a type or as a value. where it comes from. So if you use it as a type, then it's java.lang double or the primitive version. And if you use it as a value, then it's scala.double. And it's if you do the star imports, then be prepared for a lot of wasted effort in trying to make it intuitive, because it's
Okay, so
trivial.
under the star import side, if I just say, as soon as you have a name conflict, it's ambiguous disallowed. What's your opinion on that one?
So yeah, between two
Yeah, I've imported
star imports, or
I imported database.star, I've imported file.star, they both have an open. And I claim immediately, I fault you and say open is ambiguous under these imports, can't do it.
Simply don't allow star imports. It's you're first causing problems and then trying to solve them.
It's true, except that the other problem for not allowing star import is I have to fucking say whatever the name of the module is, dot everything all the time, and then that just gets
the IDE does it millions of times each day. It's not a problem.
Whether and the IDE never mind. Me and IDEs fight. I use IntelliJ all the time, and he 99% of the wrong, 99% of the time gets it wrong. It's really frustrating. Furthermore, he does a pop-up in my face that requires extra mouse or key or whatever. Emacs gets it right way the hell more often with a way stupider heuristic. I'm pissed at IDE for IntelliJ for how badly they screw up. The 99% solution is I've mistyped some minor thing. He searches the entire universe of every possible package you ever heard of for things that I have never in my life imported and will never import. And yet those are the first choices, not a one-letter typo misspelling of the thing that I've used 100 times just right here in this file.
But that's not an issue that allowing star imports will solve.
Yeah, but no, I don't see the problem with allowing star imports. So we have a difference of opinion here. I don't see the problem with allowing star imports. Long as ambiguity is avoided.
You mean it's like you need rules for having like 2 star imports where things could clash?
No. If I go to the execution model and star import is just an unpacking, then the standard shadow rules cover me. You unpack something using the shadow rules and got all the names. You unpack another thing, got all those names. Oh, you have a name conflict. I don't allow name conflicts already in the same scope. So, disallowed. So already without any other semantic knowledge, the star import didn't cause an issue with conflicts.
Then you will never be able to add anything to your prelude. I can say it's like that. So because whatever you add to the prelude, whatever name you pick, there will be an import existing in the universe that will then become ambiguous.
Yeah, right. So now the import has to use the long name version, the one that you're proposing. I have a short version as long as you don't conflict with whatever came in my prelude. Right now, my prelude consists of one symbol, which is cis.
Yeah, but the issue is that you extend the prelude and everybody else is code
The point
breaks.
of that having the prelude that way is that it doesn't ever get extended. That is the one. I only need one. I need one, but I only need one. So no more. Separately, independently, if you have to conflict with the prelude, then the new import comes in, does it the way that you're suggesting to do it all along everywhere. And then they never can have a shortcut, but I can't have the long version. That's okay. I just disallow the short version. So you said, I have to give it a name to the thing. I can't do, if I import DB, I have to say it's a DB and never say db.open, even if this file has only DB things, never has anything else in it, and the open is unambiguous all the time. I still have to say db.open. Okay.
You import db.open directly, but then you can't have another open in scope.
That's correct. I'm saying you can allow an import directly, and as soon as you have another one, you have a shadow issue, and then I claim, fail and blow you up. If you nest scopes, you get a namespace change, and you can bring another open in a nested scope. That's different.
But for what it's worth, we started with no dot star imports, but unlike what you guys are talking about, our imports don't actually execute. They are simply
independently. I can make the same semantics execute or not. I'm actually trying to sort out back to the code here. What the fuck? It was, what do you do with shadowing? Let's make sure we're clear on what I'm going to say. Shadowing is disallowed. If I say variable, like in C code, if I just said at the bottom
Do
here.
you want to share your screen again?
Sure. I'm just writing a 2-line thing, but I guess it carries on. So at the bottom here, if you're writing C code, you said int x equals 3, int x equals 4, you could get a shadowing error and it would say, error, right? So in the land of AA, the same semantics are at play. If I get rid of the word int, but it's a final assignment like that, that's a shadowing bug, and I would say no, error.
I mean,
what happens if you add something to the standard namespace afterwards, which then collides with something people chose before?
Well,
Yeah,
what
exactly.
happens? What happens if I go to Java lang import star and they add a new symbol? The answer is I get conflicts, and that happened to Java a few times in its history.
Yeah,
It
I know.
happens at compile time though.
That's correct. This would be the same. This would be the same compile time error either way. I mean, because we're not talking about eval or class for name here. We're just talking about how
But
the
that's a
imports.
pretty good example of what I was talking about earlier. In the Python case, it would blow up at runtime. In the Java case, it wouldn't blow up until the next time you tried to compile.
Okay, for me in the AA, it's the next time you try to compile this. Yeah, it's a statically typed language, so that's an error right there. So the similar error in the import syntax would be the one that says I did a star import of DB here. Let's claim that these have a funny syntax, but they're actually static imports the way that Java or C does it, right? And then someone in their code below said I had an open, I defined an open somewhere else, whatever, I could put a function here, I got the name thing. They define an open, fine. Then as soon as DB picks up an open, right? So if DB did not pick up an open, you're good. When DB picks up an open, you're bad, and you just had a shadow error. And now that's you change the API of an import. Other code that includes that has name collision issues. That's common in all import things.
Yeah,
So-
I mean, there is a reason that Java static imports are like 1.5 or 2% of all imports. Imagine we statically imported everything we used in Java, and then we would have like the same problems as we would have here.
So I have this thing where I'm writing code furiously, trying to make something new happen, and I want the least possible in my face issue. And I know I have a test I have to check. I don't know how to handle the off case. I want to put an unimplemented throw on the off case. I want to put a not defined here. I want to put a throws. I don't know yet, whatever the hell you want to call it. In Elm, it was called crash. In AA, it's called ... In Java, I wrote throw unimpl as it's long, the shortest thing I could get away with, because everything I typed in that scenario was always in my face. If some funny case, I want to go, unimpl, and I want unimpl to be unqualified because it's fewer characters to type, because it's in my flow face, breaking my flow to handle that case right now. I want to handle the main case. I'm trying to, here's where I'm trying to solve. I know I need to handle this funny case. I'll do it later. So I want to just write something as short as possible and carry on, and then go on to the next thing. And somewhere in the world, I want to say, well, unimpl, I'd rather have it be not com.cliffc.aa.unimpl, whatever the hell my namespace is. I don't want to deal with the giant thing. So I am looking for a way to shorten that. And in my case, in the case of Java, I do the static import.
Yeah, I think in limited cases it's totally fine. So if I had a prelude, I would also have like throw unimpl there, and I would also probably import it qualified into individual source files, but that has the effect that if somewhere else I'm importing a throw unimpl from, I get a compiler error, because now I have two throw unimpl methods in scope, which I'm probably not too fond of.
Yeah,
So,
so that would be one where I've picked up, like, I don't like the Java syntax. The AA syntax of that would be a lot shorter, would be.
So what does the
Right.
static keyword give you though?
it's
this case.
just Java nonsense.
No,
It-
that's my point. It's,
Yes.
it's absolute nonsense. There's no reason for it to exist. So
Well, it exists because you could have had a package with the same.
I have to include some amount of package name here. As, let me go right, you know, otherwise I do this, which is
Right.
pretty short because I picked AA to be short. And then if I don't have an import at all, then I have the horrific version, right? We all love to hate that one. No one wants to write
Exactly.
this.
Just
Read
wanted
it.
to say this. Yeah, just wanted to say the same thing. So in Go world, AA would be, I don't know, like errors or whatever. So that's how they do it. And I think for consistency reason, it makes sense to always have a package name in front of it. Probably done too much Go code in the last time.
So, right, so I'm busy trying to allow for the case where I'm going to use a symbol a lot. And not require you to rename it also. But, you know, we could argue that, I guess you're arguing, Simon, that I should just fucking rename it. At the top of my file, I would say, some local symbol named unimpl is equal to com.cliffc.aa.aa.unimpl or whatever, import, and then fully qualified name, and make a short name for it. And that's sort of the thing I hate looking at when I'm looking at people's import sections for Elm, for Python, can't say Go, where they've taken a name in a well-understood package and renamed it because they want a shorter name or they have a conflict they're working around. And so I don't typically want to support that. I do want to support unambiguous, no conflicts,
it's
short
pretty
name.
handy though, because quite often you end up with the same name being used for 5 different things. So being able to alias it is pretty handy.
Well, that's the issue here is I would prefer typically if it's going to be ambiguous, there's several that you said db.open or transaction.open or file.open, as opposed to give each one of those three opens a different name that I then have to know locally on just this file. The author wrote the names this way, and in some other file, a different author wrote the same 3 names a different way.
Yeah. Also if I'd build a new language, it would have neither star imports nor these static or qualified imports at all.
Okay.
So things would need to be qualified with their type or struct
As soon
name.
as you had giant qualifications and you're drowning and writing code that has miles of qualifications, or write shortened versions at the top, right after you did all those imports, people will say, and here's the short name for this thing, and here's the short name for that thing. And I dislike that style as well.
Having no star imports, no qualified imports doesn't solve the issue that you sometimes have to rename things, because if I do an import for whatever like DB and there is another struct somewhere that I want to import that's also called DB, then I still have an issue, but it reduces the times I need to rename in my experience, and it makes it easier to read the code, in my opinion, because you don't have many different ways of writing the same code. But
I'm claiming you force the individual authors to write many different ways to get their short names, and that's what I'm trying to avoid.
Yeah, then don't use short names. I mean,
no,
when you use.
All right, that's a different philosophy where I've totally gone down.
Yeah, I mean, it's like code is written once but read many times.
Yeah,
so it's the same. It's the same with self and this, which is optional in some languages, which I also wouldn't bother. It's like either this or
everywhere you look at it, you're making some arbitrary choices. Like in the Java case, the arbitrary choice is the only thing you can name resolve as a class, which is like, how is that a good choice? And so they added the static import, which says, okay, we'll let you resolve something that's not a class. So it's just a name resolution thing at compile time, but we'll punish you by having, adding the static keyword to it, right? So
Yeah, and I mean the biggest cost I see in that is that now you have two ways to do the same thing, and that's usually never a good approach to things. Just leave it out, leave the star imports out, leave the static imports out.
well,
And
don't mix the two of those together though. Those are two completely star imports and being able to import. Like, why not just get rid of import altogether and make everything fully qualified at every use site? I mean, start with that as the reductio ad absurdum. Like,
yeah, I mean that's
Well-
that's why it's a reductio ad absurdum, because
Yeah.
it's like I want to do the minimal thing I have to do to not jump into some absurdities, but all the additional things on top, I believe, just aren't worth it, and I don't see in the existing languages that they have been beneficial anywhere. What's your mileage?
All right. I have a different take from maybe different experience. Viva la difference. My experience was you wrote large, long, fluffy code. It had more bugs per line per unit of functionality. And it was never a win to have to write lots and lots in order to get something done. Verbosity is not necessarily your friend. And that was backed up by hard numbers on the core guts of the Java virtual machine for some enormous number of pushbacks from a large team over many years. So I'm of the opinion that I would like to allow you to write code that's fairly abbreviated already, because you're trying to solve a hard problem, and all the long names that gave you a namespace to go find where sort is didn't help you understand the problem locally.
exactly. The other thing I'd say, Simon, is that Java almost got it right in that the whole idea is that just like a compiler, to resolve a name down here off of another name, so to resolve x.y down here, x has to exist up here. And that's what import did, is it said, okay, I'm going to introduce, I'm going to alias, I'm going to register in my name hierarchy some x up at the top. I'm going to use an import statement to do that. I'm going to say import a.b.c.x, right? And so you have x up here, and then you use it down here. So it's actually, and there's no, so for moving aside dot star for the moment, which I think is safe to move aside in this context, it says at every point, the compiler can tell you exactly what a name refers to, because it's got a naming context from which it resolves that name, right? So the two things that Java didn't get right, I would argue, is that they never let you alias, because again, you're not introducing any ambiguity with an alias. And if I have two X's to deal with for whatever reason, for example, the word name, if you Command N on name in IDEA, it'll give you 472 choices, most of which start with sun.iop.corva.internal.unsafe. Whatever, like stuff that Cliff never wants to see in his autocomplete. But name happens to be a very useful interface name and class name and so on, and it's rightfully used as a name in 5,000 different places. So if you can't alias it, you're kind of screwed, right? So the other thing I'd say that Java didn't get right is that, well, obviously we talked earlier with the static thing, like they arbitrarily chose the only thing you can import as a class, right? The only name you can register in the name context is a class. That seems to be a mistake. But the other thing is you couldn't build, right? So you can't resolve a name from so in the example I typed in Cliff's in this on the page, is it still there? Yeah, so that import the capital AA, and then starting with that capital AA, I can import something else. You know, because once I import it, so don't think of the word import, maybe that's part of the problem, right? You know, alias, if you will, or, you know, enter this name into my compiler context that AA means com.cliffc.a.a, right? And now I have that name I can use. So at every point that the compiler has to resolve a name, it has it registered, it can resolve. So
Which is basically what I did in the last example. This is exactly what Go does. You always have the alias as the model name. And you can alias the model name if you have a conflict on the model name
I'm
itself.
sorry. Okay, so the last name in the import stream, this is Go here. I'm going to say Go.
Right, yeah.
The last name is what it gets imported as. And then you have to.
Most of the time, the module name can be different, but that's a Go stupidity. Most of the time, the folder name is the module name. So imagine it to be true all the time. And if you have like a conflict on the actual module name, you have to rename the module or alias the module.
Right.
And that gives you the nice consistency because you always have the same way of stuff working, but you also have the consistency of like very small things. If you like E for errors, just rename it to E.
Right. Yeah, fine.
Yeah.
It's kind of what I'm doing when my db equals and sys.import is it's to rename already to whatever you want in order to avoid a conflict on the module. So, but this, okay, so this particular version of things, okay, so it's still an import, still static declarations. You just had to do some parsing of the static declarations as you rolled forward. This is where Cameron's version of things. I don't know if this is valid Go code or not here.
Yeah, Go uses strings for the imports because you can directly import from GitHub and stuff like that. So they chose to basically put the URL into the import itself. Was probably a good idea for Google itself.
So what I'm saying is having imported AA.standard errors under the name errors, I can now use that as part of the next import statement where I say errors.some more. And it's actually the full name of just picks up an
Yeah. Yeah, Scala has this functionality and nobody ever uses it.
Okay, fine.
So does that mean you're
I sometimes
reusing
use
the
it.
previous import to import something further down?
Well, that was the question I was hearing originally. And maybe I don't care, like you know, you say Scala doesn't use it. I'm looking at that thinking, I don't have that many imports at the top of my method that I actually want to use the short one from the first guy in order to shorten the strings on the second guy. That's not a problem I run into. So I don't care.
I mean, you're probably right this
another
point,
thing,
right?
if you could put an import anywhere though, if imports were scoped, it would become suddenly a lot more useful.
Oh, I see import in a scope. And this is still static, you're saying. There's no
Yeah,
dodging it.
I think C# did it before, and I don't think they use it much either.
Yeah,
Because you have to imagine, it's like you want to get to in 90% of the cases you want to get to whatever Scala collection mutable, but doing these scoped imports also means you bring everything in scope from Scala, everything in scope from collection, in addition to Scala collection mutable, and that's usually not desired.
Yeah.
right. And and I think the problem with the errors, some more errors. How would you differentiate that from just being a folder errors with a subfolder some more errors?
Yeah.
Because you name stomped it as soon as you said AA.standard errors imports as errors.
Right, but that could, so you're not sharing. So so the problem is if you consider that folder names, that would be a folder called errors. How would you make sure that is not before?
The
right?
name itself is ambiguous. It can be a folder, it can be a class,
Right.
it can be entity. It can be something that you import in your code.
Or you have to do something like / to make sure you're actually getting a file.
Well, that was
I
that's a
believe-
different question. So what's it mean to import a module?
Yeah.
And in the case of Java, it means there's a jar file floating around, the .class file floating around. In Python case, it generally means you got some code, you're going to go suck it in and eval it under the hood.
If you have a namespace, then I believe this should be ambiguous. It shouldn't fix exactly what you're referring to.
Well, the import more errors, some more errors there is unambiguous in my head, at least, because the first name hid the local errors. And I could argue that I would give you a link time error claiming in this context, there is an errors file. And also you imported something as errors, and that's ambiguous. So I'm going to hate on you.
Yeah.
But that would say in the world where this code is being linked, if you will, it would be an error to have an errors module floating around because of ambiguity. So if I change where this code is being evaluated from, in some cases, it's going to run just fine. In some cases, it's going to say, I have a name conflict with the local errors name that you have, even though I unambiguously am referring to AA.standard.errors.
But do you want that to happen just in case somebody's reusing your code and try and compile it?
Yeah, I'm actually of the opinion that this is like a mistake. So for the reason that I don't need to have this. Now, the case where you import in the middle and you want short forms, I don't know how to solve that. But I would take the example that I already wrote and write it like that.
Right. Yeah. Okay. Got it.
Right, and claim that this is buried. So this example here, I know how to resolve it unambiguously. I don't claim it makes for easier to read code though. Maybe it doesn't. Whereas if I want to throw an import in the middle of a file, because I want to just bring in the database namespace for this little SQL query and get rid of it, because I don't want all the DB things that come in. I just want to open a fucking DB, squirrel question for all the people's names, and then close it and be done. Why not allow that to happen? And then do I care for a short name on that? I don't know.
Rust spent a lot of effort on the relative import versus absolute import thing. And the more, because intuitively you want to have absolute imports in your import statement itself. But when you want to qualify things in your code, then you usually or intuitively expect to use relative imports. And honestly, the more I look at it, I say, well, let's go to Java roots, no rename, no relative imports. If you need to use two things with the same name, you have to fully qualify one of them. It's not nice, but the complexity you avoid by like not having some sophisticated mechanism is worth it. Let me see whether I can find a Rust.
Yeah.
This should be an error because you declare its scope.
Python do relative imports, and I kind of didn't like them either. Like the package import system says, I'm unwinding the length, the count of dots in the package name. I went up that hierarchy in a tree-shaped file hierarchy, and I found everything relative to that. And I'm okay with that version of things. And then there was a Python thing that said, I'm doing a relative package name, and I went ... and then I said / and started going downhill again.
Same thing for Node.js. It's it's horrible.
Okay, fine. So that would be a no then. I can agree not to do that.
Yeah, and it's the biggest problem with that is when you move something around, because you need to have good refactoring support, otherwise everything breaks.
Ah, yes. And if you have an absolute to a tree-shaped file hierarchy system,
it doesn't matter, right?
Yeah, right. Yeah, I can buy that.
I added the link to the changes Rust did in 2018, and they basically say, well, we did 6 changes, and those might look arbitrary, but they really, really improved things. So yeah, that's 6 more rules you need to know about imports, and I'd rather have 6 less rules to remember about imports. And if saying you have to qualify names for that, that's, I think, a reasonable choice.
I'll go read it later. It looks good though. Yeah, modules are always a bitch. I'm back and forth on, you know, the Cameron, you're talking me into C model versus C Java model versus the Python model. I know the Python model leads to kind of rat holes.
Yeah,
JavaScript.
Python and Ruby are really cool how they do it, but it's in conflict with what you're trying to do. It's what I'm trying to get across. Like you can't, like I like Python and Ruby. I just wouldn't run any multi-threaded workloads on those things.
Yeah, multi-threaded, it's not the issue. It's just still a whole game of go find all the code, like the closed world versus open world model. The multi-threaded here, I can totally sort out in a straightforward way, and you would get same as Java, whether you like it or not, Java under the hood, loads classes dynamically,
Right, but they're
multi-threaded,
fixed.
parallel.
They're immutable once they're loaded.
And they're immutable. Yeah, this would be immutable once loaded as well.
Well, right.
Maybe Pythons aren't, but my classes will be statically typed immutable after loading. That's not the issue.
I'm saying that is the issue for Python.
Okay. All right. It could be. I don't understand why it's an issue per se, but I can believe you. If you don't have the class loading process itself be concurrency safe, you have weird immutable things going on.
By the time they got around to thinking that they'd like multi-threading, they had, 12 billion lines of code.
Right.
And then they're like, okay, let's add multi-threading to this.
I thought they choked up on the GIL. You're saying they choked up on the class loading, the module system?
They choked up on the fact that their type system is perpetually mutating. And that doesn't work in a multi-threaded
Oh, that's
system.
different yet again.
Yeah. And they
actually mutating.
and they basically expose all the runtime and compiler internals
As that.
completely. It's like you can do you can write a C module for Python and then change things around in the Python interpreter from the C module. And there are things like, okay, I can have a look at the locals defined at this specific place in my source code according to the interpreter and have a look at that from the C code. And because you basically
Java does that. Whether you like it or hate it, that's what Java breakpoint does. He takes a safe point, stops you, figures out what the damn Java execution state is, and hands it to you.
There's never a safe point in Python.
All right, it's all safe points in Java all the time, except that it's not for speed. But effectively, we cheat to make it go fast. But you can go ask for an interpreter state, and he'll give it to you.
I guess what my point is Lisp is cool, Ruby's cool, Python's cool, but you're building something that's not at all like that. And there's a reason.
Yes. Yeah, no, I want my static types. And then I don't typically want people to go reach in and hack those things on the fly, like reflection changing finals is a no-no.
Right, exactly. And what I was going to say earlier, Simon, is that we started with a rule of no dot star, none of that crap, because again, like thinking like someone down the road adds something and it causes a problem and all that. We backed away from that early decision. So we could not justify avoiding the dot star imports, if you will. And the reason is because there are a lot of places where you have, a package that has 300 classes in it. Yeah, they're small, like ops in an IL. Every op is every AST node is a class. And it's a beautiful way to build code in an OO system. But if you have to import those all by name, like you end up with a file that's 372 lines, of which 369 are
My
imports.
IDE writes these imports in
But I
millis-
don't need to have textually represented in my code that way. It doesn't help me at all.
So Simon, I just want you to know, I agree with you. And then I went through the ringer and I grudgingly now disagree with you.
Well, I would even go further. I'd say like if I'm writing a file or a class or a type in package foo.bar, other types in foo.bar shouldn't be implicitly imported. I wouldn't even allow
So-
that.
I like to think of it as a directory system on disk. And it's like, if I'm in the current directory, I want those names there. Everything in the directories under me, I want to be able to refer to them by, directory name dot file. Like everything is everything. If it feels like a directory system, I think, I'm not saying that's the right way to do it. I'm saying
No.
it's a way that developers will understand.
Yeah, I mean that's definitely an argument for it. What I see is that if you don't have star imports, as mentioned, and also don't have these implicit imports for the same package, it means that everything you use in the file is explicitly mentioned at the top. There is absolutely no magic. If you don't have an IDE on your mobile phone, you can use grep and it will be correct. You can do renames with an regex and it will be correct because there
I don't
up-
agree with your
no man-
conclusion, but I
uh,
agree with your rationale. Your rationale is beautiful. Like, I just don't agree with the conclusion.
By the way, I preferentially use Emacs and grep over the IDE hunt because it's typically faster and gets things the IDE misses. And I can step through the mistakes like, oh, I should have picked up that one. And the IDE only got the exact name hits and all the near misses and comments and shit. Grep's good.
Yeah,
I use them
if-
both, and Intel and Emacs has an IDE like lookup as well. But grep is my friend for sure. Good tight
Hey,
integration
that's
between
good
Emacs and
advice.
grep.
Yeah, I mean, if everything is explicitly imported, then you can write your refactorings with set, and it works.
No, and I never have a refactor. Never. I said that's too strong a word. I rarely use the IDE refactoring. It does a few refactorings correctly well, like a bulk name change. My usual refactoring rule requires me to make edits at every use point and every def point that are common. I understand what they need, but they're not a standard IDE pattern or a regex kind of thing. So I have to visit all call sites. And the usual easy pattern for that one is I change the canonical call I'm trying to do such that it fails the build. I hit the build button in Emacs and start stepping through the errors. That's faster than any refactoring
pick up the
games I've ever
pieces.
got out of the IDE. And 20
Yeah,
20
sure.
lines of hack, one each for each call site that's a little different. Later, I'm done way the hell faster than if I'd attempted an IDE refactoring. Renames IDE can do. Emacs does it pretty quick too, pretty well. Outside of that refactoring, the IDE refactorings don't do me any good at all.
I think the worst decision anyone could ever make is include strings into refactorings. IntelliJ does that by default, and it's horrible.
Yeah, I like it that it's gets listed as an optional part, and then you can have a look at
But
it.
it's opt out. That's the problem. It should be opt in.
Yeah, I've been bitten by that so many times when I have one word method names, like whatever, rename interrupt. And it's like, oh, why did I just check out every file in the code base? Oops.
Right.
No, I had a pretty good impression of at least IntelliJ for Java finding fully qualified class names in very weird places where I would have never looked. So
I
That's
agree.
not the issue that I have, though. The issue that I have is that either the refactoring wants something more complicated than find them all, which grep does pretty good at, but it also fails to find near misses. And grep will find me near misses where I have used the wrong name or the wrong function or the right arguments, or the comments are referring to the issue in question, but it's not actually use of the code, but it's a dependent section, which now I have to pay attention to because I wrote a comment to myself here for a reason. Hey, this code depends on this blah, blah, blah invariant. I grep for blah, 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 and it popped out in the comment as you did something here and you need to go pay attention. And the IDE, like, I found all instances of your function call, but that wasn't all the instances I cared about. So that's, you know, I'm not claiming that it has no use. I'm just saying there's strong uses for grep that I run into daily basis that I can't get out of an IDE and I don't expect to. And I'm gonna have to call quits, and I hate doing it because we're like mid cool shit, but it's not only late, but my wife wants me to step her through fixing the lawn.
And I'll just say, once you learn how to use IDEA, it's a lot better than that.
So the claim is made, and I've had a lot of people
Know
rate
your
me,
tools.
and I've looked at what they do, and I'm hell of a lot faster not using the IDE.
It's,
And they are
it's not
using
just
the
about,
IDE. I'm just
it's
like,
not just about speed. It's not just about speed. It's
you
also
know,
about,
I could go
it's
down that
also
path
about the
too.
size. It's also about the size of the context you have to hold in your head.
Yeah,
And it's
yeah, I
pretty-
agree.
It's pretty
Yeah.
good at unloading that. I'm impressed. I came from slime, slip.
Hmm.
Yeah,
editor?
slime is,
Slime.
Yeah.
Slime.
yeah.
Yeah. And but I grudgingly learned how to use an IDE. I got to admit, it's pretty amazing.
It does some things well. I'll give it that. The Emacs IDE lookup thing that it does is not as precise as IntelliJ. So there are times when IntelliJ gets the big win there, and then that's fine too. I use them both.
We will revisit the IDs next time.
Next time. All right. Good talking. Bye-bye.
Are you sure you want to do that?
Yeah.